So now we're recording, guys. All right, so you got a question for what?
Number 8.
Number 8. Let's look at number 8. Number 8 says g of x equals 3 times the square root of x. All right, so sometimes what happens when we get used to like doing a certain thing, so for example, we've been doing derivatives of functions, we end up doing two things, and sometimes we forget that really this simply means what? 3x to the half. Let me make that easier, right? This is really 3x to the half. So now all we do is what? Who asked me the question?
I did, Arthur.
Arthur, what would this be? This was number 2. 5x to the 18th. What's f prime? Well, what do? We know that we take the 18, bring it out here. 18 times 5?
90.
X.
To the 17th.
And then 18 minus 1 to the 17th. All righty. Well, the only difference here is all we had to do was realize that the square root of x can be written as x to the half. So now we're going to do exactly the same thing. We're going to take the half, bring it out here. And don't put 1.5, just put 3 halves. X. And then all we're going to do is subtract, well, 1, 2 over 2. So that becomes what? To the negative 1/2. Make sense?
Yes, sir.
All righty. Did you try to make it like something that it wasn't?
I didn't do the 1/2 part.
I got you. Okay, cool. All right, so let's just always remember, like, it's sort of like, hey, listen, if you're on an airplane and like the right engine goes on fire, like the first thing the pilots do is they whip out the manual and they just go through everything in their manual so that they don't miss anything, right? You're doing the same thing. You just have to know exactly what it is you're talking about. So sometimes, like when you watch like that show Air Disaster, right? Sometimes they don't actually know what's going on, and it makes it more difficult for them, all right? Does that make sense now?
Yes, sir.
All righty. So now, what if we look at something like number, let's look at an easy one, number 4. F of x equals 4x to the 4th minus 5x minus 3. So now all we're doing in order to find f prime of x, we're taking all those little rules we learned. Power rule, constant rule, all right? Sum and difference rule. We're going to put them all together. And we know we have 3 different terms here. So all we're going to do is take each of those terms and find the derivative of each of those terms. All right, so the first term there, 4x to the 4th becomes what? Well, 4 times 4, 16, 4 minus 1 to the 3rd. And now this one, don't forget, there's a 1 up here, right? So that comes out to the front. 1 times negative 5, negative 5. 1 minus 1 is 0, and anything to the 0 power is simply 1. And then if we have a constant, we know that that's 0. And of course, we would never write that. So there's our answer. Did everybody get that? Hello?
Yes, sir.
All righty. Number 7. What you getting, Moten? Moten.
I'm on mute, sorry. Negative 9x to the negative 4 for my answer.
What you get?
Negative 9x to the negative 4.
Beautiful. Let's make sure we know how we did it, fellas. Hey, we can rewrite that as what? What do you do?
3x to the negative 3.
That's right. And then we just simply use our rules. So negative 3 times 3 is negative 9x. And the mistake people might make if they hurry, They see a 3 and a -1, they go -2, but we know that that's not right. We know that it's what? Minus. So, you know, you can actually go like this, -9 over x to the 4th. That would make the x positive. Does that make sense?
Yes, sir.
All righty. Now, how about we look at number 9, right? Number 9 says f of x equals the natural log of 4x squared. Now, this one, gentlemen, is what? This is what we were talking about last week at the end of the week, right? What we talk about, what rule is this?
Natural log rule.
We got the natural log thing. How do you find the derivative of the natural log? But we also have what going on? We have the chain rule because we have two different functions. So like this is actually your two different functions, fellas. The natural log of something, and then the other one is what? 4x squared, right? So what we learned was that if we wanted to find this, all we would have to do is take this and then multiply it by that. All righty? So when you look at this picture, let me get rid of this. When you look at this picture, what you want to do, all right, you want to look at it this way. Ready? Let me get rid of this. You want to look at it this way. All right? And those are your two rules. So the first thing we're going to do is pretend this just said x. Well, what's the rule? What's the rule?
1 over x.
It becomes 1 over x. But it's not x. What is it?
4x squared.
Yeah, it's 4x squared. So it's 1 over 4x squared. And to that, we are simply going to multiply g of x. So what's the derivative of that?
8x.
8x. So that's 8x over 1. Now, so f prime of x would simply be 1 times 8x, right, over 4x squared. That makes sense? So 2 over x. Would you get that? Possibly, right? Hit it up. That's algebra, right?
Yes, sir.
All right. Does that make sense? Who remembers the rule for this one? If I tell you f of x is e to the 2x, right? If I tell you f of x is e to the 2x, what's f prime of x? Well, my question to you is, this is not the same as this, right? Those are two different things, fellas. That's easy. What's the rule? What's the rule when you have base e? How do you find the derivative?
Base just itself. And then
It's the same, right? But that's not what we have. What we have here, right? What we have here is e to the 2x. So what did we say when we have to use the chain rule here? We have a function. We have a function e to the x of a function 2x. So what did we say the rule was? Well, the first thing we're going to do is, what do we say the first thing you do is? Copy. And then what are you going to multiply that by? The derivative of that. What's the derivative of 2x?
2x, or just 2.
2. All right. So f prime of x is going to be what? 2e to the 2x. Make sense? Once you see base e, it's pretty easy. Copy and then multiply it by the derivative. All right? Now, I want to see how many people made this mistake. All right. Let's look at the next one. F of x equals 3 times the sine of x. All right. Now, Cody, what you get?
-3 cosine x.
-3 cosine of x?
Yes, sir.
All right, so Cody says -3 cosine of x. How many people agree with him? Hello? How many people don't agree with him?
Yeah, just 3 cosine.
Yeah, it's not negative, right? So Cody, remember, if you have f of x equals the sine of x, the derivative is cosine of x. But when you have f of x equals the cosine of x, then the derivative is negative sine of x. Does that make sense, Cody?
Yes, sir.
All righty. Now, so we didn't, I was kind of hoping nobody used the chain rule, right? But we're going to use the chain rule for number 12, right? G of x equals the cosine, not of x, but of 2x. So there's your two function, the cosine of something and 2 times x. So what we're going to do, right? What we're going to do, let's find the derivative of that. Well, the derivative of cosine is what? Negative sine, but not of x, but of 2x. And to that, we're going to multiply the derivative of that. What's the derivative of 2x?
2.
2. So our answer, the derivative of g of x, is simply going to be -2 times the sine of 2x. Does that make sense, fellas? Anybody have questions on that?
So like, when do you know like when to use the chain rule and when not to use the chain rule?
So this, for example, all right, so like, hold on one second. This example is the chain rule because I got two functions. Here are my two functions. Ready? My two functions, the cosine of something other than just x, all right? And then the other one is 2 times, instead of x, f of x equals x. Well, that's not what I got. What I got is f of x equals 2x, right? G of x equals cosine of x, but that's not what I got. What I got is I got two things going on, right? So what you do in this case, right? So it says g of x is this whole thing, right? It's the whole thing. G of x is the whole thing. So all I'm going to do is I'm going to find g of f of x, g prime, right? So because g of x would be the whole thing, right? And I break it up into 2, so I just simply find negative sine, but not of x, but of 2x, and then I'm going to multiply it by the derivative of that, 2. So if it said this, that's not chain rule. That's not two different functions. That's just one function. That's the cosine of x. All right, does that make sense?
Yes, sir.
This becomes the chain rule because now I got two different functions. I'm taking the cosine of x, I'm multiplying x by 2. F of x equals 2x, right? Does that make sense?
Yes, sir.
All right. All right, so is everybody clear on that? All right, everybody clear on that? All righty. So now let's review. All right, we're going to review how we go about finding limits, right? That's been about a week and a half ago now, right? I think, right? And then finding derivatives, right? So you're going to have a quiz, right? And you know, limits, they shouldn't be too hard, but sometimes they get a little confusing, right? Sometimes they get a little confusing, right? So let's just make sure we know what we're doing. I'm not sure how far we're going to get. We might get through all of the limits and the derivatives. We just need to make sure we know what we're doing. All right. So let's go back to what we did, or what you did with your work on limits. All right. So this is what we mean. Calculate the limit as x approaches a of f of x. That's really what we're talking about, right? So did Miss Dalmage do this? She did this graphically with you too, right? Hello?
I think so.
All righty. So why don't we do that first, right? Why don't we do that first, right? I'm gonna set up a graph here, right? So there's my y, there's my x. And of course, y is equal to f of x, right? Right. So if I have some type of function, I don't know what it's going to look like. Let's make it look like this. Ready? Everybody can see that, right? And now I go like this. So if I said to you, right, if I said to you, what is the limit as x approaches 3 for this function, right? This function f of x, right? All right, now, so I would simply look at my picture. All right, that's where, now, when we are trying to find a limit, what we're trying to do is try to figure out what my function, what number my function approaches as I get closer and closer to this value 3, right? From both sides, either from the left or from the right. Does that make sense? Well, I know that if I was here, there I am. And if I get a little closer, there I am. And if I get a little closer, there I am. And we know, based on what that I can get infinitely close to 3 from the left. And as I do that, what am I approaching? I am approaching whatever this value is here. All right? It's f of x, right? Now, when I approach from the right, so like when I'm out here, I would be all the way up here. And then as I get closer, I'm here. And as I get closer, I'm here. And as I get infinitely closer to 3, my function is actually getting closer to this value right here, whatever it is. Does that make sense? So when you have a picture, it's kind of easy to tell, right? Sometimes. Now, sometimes it's not so easy. Sometimes you end up with something that looks like this, right? Nope, my bad. This is f of x, and this is x, all right? Sometimes you get a picture that might look like this. Let's see. Now, we know that we have some type of discontinuity. However, that doesn't mean we don't have a limit. So for example, if I said to you, at x is 2, what is the limit as x approaches 2 of this function? All right, let's see if I have one, all right? Well, as I come from the left and approach 2, what number, if there is one, is my graph approaching? Well, as I come from the left, right? Whatever this value is right here, whatever it happens to be, right? That's the value I'm approaching as I come to the left, from the left. But if I come from the right, as I get infinitely closer to 2, what value is my graph approaching? And in this case, it's the same. Now, if I said to you, what's f of 2? If I just simply said to you, what is f of 2? Well, what do you know about f of 2 in this diagram? It's what?
Not there, it's removable.
It's undefined. It doesn't have a value. However, the limit does have a value. Whatever this value is right here, that's the limit. Because even though it's not defined at 2, I'm asking you what's the limit as we approach 2. Does that make sense? So even though we have a discontinuity here, it doesn't mean that there's no limit. Does that make sense? Because now I'm going to show you what happens in this scenario. All right, so I got f of x, and I got x. And quite honestly, fellas, I really don't care what the picture looks like, right? Doesn't matter what the picture looks like, all right? So now, I tell you, I want to know what is the limit as x approaches 1 of f of x. Like this is simply the picture of f of x, right? So once again, all I'm going to do as I approach 1 from the left, what value is my graph approaching? Well, whatever this is right here. Does that make sense? Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
As I approach 1 from the right, what value is my picture approaching? Well, it's approaching this value. So what happens? What do we say about this one? We say that there is no limit because as you approach from the right and the left, your graph is not approaching the same value. Now, we're not talking about one-sided limits yet, all right? We're just talking about finding the limit. All right, does that make sense? What do you call this discontinuity? What do you call this type of discontinuity?
Jump.
Jump. Good. All right, does everybody understand the difference between those 3 pictures? All right, hello?
Sir.
So even though this picture here, oh, my bad. Even though this picture here, right? Oh, I'll get it right eventually. Even though that picture right there is undefined at this value of x, it still has a what? A limit. Because as you approach this value from the left and you approach this value from the right, your graph approaches the same number. Now, at this point, it's undefined, but that's not what the limit's asking for. Does that make sense to you guys? Hello? Does that make sense? Hello?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So I don't think finding your limits graphically will be a problem, right? So, but we know that graphically, well, a lot of times we don't deal with graphs. We talk about algebraic, all right? So I'm pretty sure Ms. Delmage did this with you too as well, right? Yes?
Yes, sir.
All righty. So what's our first, who remembers what's the first thing you do when you try to find an algebraic solution to for a limit?
Just like substitute
Yeah, direct substitution, right? So you want to do direct substitution, right? Now, and the reason you do that is so that you don't have to do a whole pile of work, right? Sometimes when you do the direct substitution, you actually get the limit. Now, sometimes you don't, but you always do the direct substitution first because you want to make sure, hey, do I have a limit here? So let's see. So if I do direct substitution, right? So if I say to you, what is the limit as x approaches some number a of f of x, right? Now, if you do direct substitution, right, and you get a number, right? So b, right, if you get b is a number, right, right, then you are probably done, right? Now, notice I said probably, right? The reason I say probably is like when you have some type of discontinuity, right? You might not be done, but you might be done, right? All right, so what you got to do is you direct. So for example, if I give you this question, what is the limit of the function x squared? What is the limit of the function x squared as x approaches 3? All right, well, if I take direct substitution, I'll just take the 3, put it where I see x, and I come up with 9. All right. Well, I put the direct substitution in there, and I got a number. I'm pretty confident that that's going to be my limit. Well, let's just show it. If it was a graph, it would look like this, right? What's x squared, fellas?
Parabola.
Parabola.
That's x squared, right? So x to the 0, right? X to the 0. What's x to the 0?
0.
What's anything to the 0?
0.
All right, x to the first, it would be x is 1. What's 1 squared?
1.
1.
1. X squared, 2 squared?
4.
4. 3 squared?
9.
9.
Yeah, that's about 9, right? So if I had a graph of that, as I approached 3 from the left, and as I approached 3 from the right, what value am I approaching?
9.
Well, 9. Make sense? So there's your algebraic solution, right? So anytime you're looking for an algebraic, trying to find a limit using algebra, the first thing we want to do is directly substitute a value into the function. And if you get a number, a real number, b, you can be pretty confident, fellas, that that's what your limit's going to be. Not all the time, but pretty confident that that's what your limit's going to be. All right? Now, makes sense? So far, so good? Now, sometimes when you direct substitute, you don't get that type of number, though. Sometimes you get, all right, you get something that looks like this. I take my value, I put it into the function, right? All right, and I get b over 0. I get a number over 0. And b can't be 0. That means b is some other number, but your denominator is 0, right? Here's what you know, fellas. When you have that, you are pretty confident that what you're going to have is a vertical asymptote. All right? You're probably going to have a vertical asymptote, right? So what does that mean? Well, let's try one. Let's try one. Everybody following so far? So sometimes, first thing we did, sometimes when you substitute, you're going to get a number. When you get a number, we're pretty confident that that's what the limit's going to be. Sometimes when you direct substitute, you get a number over 0, right? Some number that's not 0 over 0, right? So for example, I'll give you a little diagram here, right? So here we go. What is the limit of the function 1 over x minus 1? What is the function of the limit 1 over x as x approaches 1? All right. Well, if I direct substitute, I'm going to get 1 over 1 minus 1. So what do I get? I got 1 over 0. So now that I see 1 over 0, I'm pretty confident that I'm going to have an asymptote. Now, what does that mean? Well, fellas, when you have 0 in the denominator, that's an undefined expression, right? Yes? So here's what I know about my picture. When I go to 1, I'm going to have a vertical asymptote. Because at 1, my function is undefined. And hopefully, I don't know how much work you might have done on this, but you should understand that this picture is going to look something like this. All righty? So now what happens? When I approach 1 from the left, and I approach 1 from the right, what am I not getting closer and closer to? The same value, right? If I approach it from here, I'm just getting further and further up here. If I approach from the left, I'm just getting further and further down here. So there's an example, all right, where that's probably what you're going to have when you direct substitute and end up with a number over 0. Does everybody remember that? This is review, right?
Yes, sir.
It is. All righty. And then finally, sometimes when we direct substitute, we don't get a number over 0. Sometimes when we direct substitute, we don't get a number over 0. We get a 0 over 0. So for example, what is the limit of the function x squared minus x minus 2 over x squared minus 2x minus 3 as x approaches -1? All right, so you have a rational function there. If I directly substitute -1, right? So I got -1 squared is 1 minus a -1 minus 2. All of that over -1 squared is 1, right? -1 times -2 is +2 minus 3. Well, if I do this up top, right? 1 plus minus a negative is 1 plus 1 is 2, minus 2 is 0. 1 plus 2 is 3, minus 3 is 0, right? So when you have 0 over 0, first thing you got to remember, fellas, a number other than 0 over 0 and 0 over 0 are not the same thing. B over 0 and 0 over 0 are not the same thing, right? When you have this, you're pretty sure you have a vertical asymptote, right? Does that make sense? All righty, so just remember that. What happens when I have 0 over 0? Well, we call that indeterminate. Indeterminate form. All right, now, when you have indeterminate form, what your problem is the form, right? So we can change the form. And depending on how, this is the one that gives us the most work to do. So depending on how you, or what you have, right? Depending on what you have, you're either gonna factor, you're gonna use a conjugate, or you're gonna use some trig identities. Now, I'm not sure what Miss Delmage has done with you. She did factoring for sure, right?
Yeah, we did factor.
Did you do conjugate and trig identities?
I don't think so.
All righty. I don't think so either, just from looking at the quiz, but we'll figure it out in a second, all right? We'll figure it out in a second. We'll do the factoring. We'll make sure we know how to do the factoring, right? So if I give you this question, right? Let me erase this, ready? Here's your question, all right? What is the limit of the function x squared minus x minus 2 over x squared minus 2x minus 3 as x approaches -1? Well, we know that when we direct substitute, what did we get?
0, 0.
We got 0 over 0. Now, I know that now I got some work to do, all right? So what I'm gonna, here's what I do know. X can never be what?
Negative.
How do I know X can never be -1?
Because you'll get 0 in the denominator.
Because when X is -1, what do I get in the denominator? I
Zero.
zero. So I'm gonna talk about like when X is not -1, right? So here's what's gonna happen. I look at my picture here, I look at my function, and I know I'm not gonna use a conjugate simply because I don't have a variable under a radical. I don't see a radical. I know I'm not going to use a trig identity because I don't see sine or cosine, but I do see polynomials. And what do we learn how to do with polynomials? We learned how to factor them, right? So what I'm going to do is I'm just going to take those and I'm going to factor that. So when I take my numerator, right, x squared minus x minus 2, all right, I'm just going to take this numerator right here, and I'm going to factor it. And what am I going to get? I'm going to get x minus 2 times x plus 1. Do we all agree with that?
Yes, sir.
Yep. And now I'm just going to factor this. I'm going to factor the denominator. And I'm going to get what? X minus 3 times x plus 1. That makes sense? Now, hey, fellas, you do realize, like, if you don't know how to factor, you're in serious trouble. So we're going to be reviewing factoring rules, all right? But does this make sense so far? Hey, what are you going to do now? What do you notice here, fellas?
Cancel out x plus 1.
Those factors, x plus 1, cancel, and I am simply left with x minus 2 over x minus 3. All right, does that make sense? Now, here's what I remember. Don't ever forget this. X cannot equal -1. Because if x equals -1, what do I got? I got an undefined. So this is not, right? Does that make sense? So now all I'm going to do, once I have this new expression, now notice, we called it indeterminate form. Well, now I have a different form. So now I'm going to substitute. I'm going to take my -1 and put it into my new form. So I got -1 minus 2 over -1 minus 3. This becomes -3 over -4, and negative over a negative is positive. So there we go. Now, here's what I do know. I am approaching, as x approaches -1, my limit is 3/4. I know at -1, it's undefined. Does that make sense, fellas? Does that make sense?
Yes, sir.
All righty. Now, so sometimes that's what you have to do. Now, I'm not sure. I'm going to write down a problem. You let me know if Ms. Delmaz got into this at all. She might not have because of all the problems we've had with school, like the coronavirus, right? So there's your question. All right. What is the limit of the function, all right, the square root of x minus 2 over x minus 4 as x approaches 4? Did Ms. Delmaz do something like this with you?
Yeah, I believe so.
All righty. So here's an example. If I direct substitute, right? Always when we're finding a limit, we direct substitute. So the square root of 4 is 2 minus 2 over 4 minus 4, right? What do we get? 0 over 0. So I got the value by direct substituting that tells me I got more work to do. Now, this one, I see this expression. So I'm thinking, oh, I need to actually do what? I need to use the conjugate. Who remembers how to find the conjugate of this thing right here? Yes? Yes? Hello? Is that how you find a conjugate? How do you find a conjugate of a binomial?
Opposite.
Just change the sign in the middle of it. All righty? And now let's simplify. Well, fellas, what's the square root of x times the square root of x?
X.
X. This times this and this times this is going to cancel, right? And then this times this is minus 4. Now watch. What have I got down here? I got x minus 4 times radical x plus 2. And what happens to this?
Cancels.
That cancels. And what are you left with? 1 over radical x plus 2. Did Miss Delmaz do this with you?
No, I don't think so.
All righty. Well, that's not that big a deal, right? So now, what's the value as x approaches 4? Put it in there. 1 over, what's the square root of 4?
2.
2. 2 plus 2?
So
4. There you go. Makes sense? What do we know x can't be, though?
4.
It can't be 4, right? But we can tell you what x approaches as the value. We can tell you what it approaches and we approach 4. Does that make sense?
Yes, sir.
Yes, sir.
All righty. So really quick before we end up, what the hell time is it? We got a couple of seconds, ready? So let's go back. Limits. Right? Because this is on your quiz, right? You got 2 questions on your quiz. Ready? Limits. What we want to do is do direct substitution. When we do direct substitution, we're going to get one of 3 values. We're going to get something that looks like this, or something that looks like this, or something that looks like this. That's the 3 things we talked about. Well, we know, fellas, if we get that, we're done. Most likely, if you direct substitute and you get a real number, you're probably done, right? If you direct substitute and you get some number over 0, you are pretty confident that you are going to get a vertical asymptote, right? No limit. All right, does that make sense? If you get 0 over 0, you know you got work to do. And what could that work be?
Factoring.
Well, for us, it's going to be factoring. Or it could be a conjugate. Or it could be a trig value, trig function, trig identities, okay? Does that make sense? But here's what you got to remember. Direct substitute, and then see which of these you get. Does that make sense?
Yes, sir.
Now, what you got to realize, fellas, these are all algebraic ways. Next year, when you're taking calculus, you're going to use calculus ways, right? But right now, all you got is algebraic, right? Does that make sense?
Sir.
All right, let's try another one. Do you want to do one more? You want to do one more? It's 10:49. Let's do one real quick. Ready? The limit as x approaches -1 of x plus 1 over x squared plus 3x plus 2. All right. So we know the first thing we want to do is direct substitute. So in my numerator, if I put -1 in there, -1 plus 1 is 0. If I put -1 into the denominator, 1 minus 3 is -2 plus 2, 0 over 0. Hey, fellas, looking at what they gave you, I got 0 over 0. I got work to do. Do you think I'm going to use trig identities? I don't think so. Do you think I'm going to use a conjugate? I don't think so. I don't see any radicals. What do you think I'm going to do?
Factor.
Yeah, I'm just going to take the numerator. That can't be factored. Hey, factor this. X plus 1 times x plus 2, yes? The factors of the constant that add up to the coefficient of the x, right? So there we go. And what can you do here?
Cancel.
And what am I left with? 1 over x plus 2. Now what do? Just substitute the -1 into that. Now, what do we know x can't be? Don't forget,
-1.
One.
can't be -1. Very good. So what's -1 plus 2?
1.
Yeah, so we got 1 over 1. What do we got?
1.
So our limit as x approaches -1 is going to be 1. Does that make sense? Not that big a deal, right? All righty. That's all I got for today. That's a lot of work. That's a lot of review work, all right? So let's make sure we remember that. Go back into your class notes and see some examples, all right? And then when you come in on Wednesday morning, we'll go through all the rules for the derivatives. And then you will have a quiz that's going to be due Friday at midnight. Does that make sense?
Yes,
Sure.
sir.
And it's only 5 minutes. It's not going to take you long to do. Fellas, I think you're pretty good at this. Does that make sense?
Sure.
Anybody have any questions right now?
No, sir.
Oh, Dylan, you look like you're awake. Wow, look at that.
I've been awake the whole time, coach.
Oh, yeah. All righty. You guys realize I can't see a damn thing when I'm on this whiteboard. Oh, now I can see you. Wow. All righty. And so hey, fellas,